In Chapter 5, we will be talking about polynomial functions. So a polynomial function simply means that we could have something as simple as y equals mx plus b, the equation of a line, y equals ax squared plus bx plus c, the equation of a parabola, y equals a times the absolute value of x minus h plus k, the polynomial, the function of a absolute value. But it could also mean that we have x cubes or x to the fourths or x to the fifths. So there are a couple of things that we will know about the graph of our polynomial based upon how many terms there are, by the degree of the polynomial, and what the sign of the leading coefficient is. So a coefficient is the number in front of each x, or of each variable. So that's the number in front of each variable. To be a leading coefficient means that it's the number in front of the variable with the highest degree. So the first thing that we want to do is to make sure that our polynomial function is written in the correct order. So just like we have standard form of a quadratic where we start with the squared term and then the x term and then the number, in any polynomial, standard form means we start with the degree of the highest degree and work our way on down. Now, a great deal of what we're going to be looking at today is just terminology. So, first of all, when we're talking about polynomials, a monomial simply means that there's only one term. Examples of monomials are things like x, 4y, 3, 7x squared y, etc. One term. A binomial means that we're adding two monomials. A trinomial means we're adding three of them. And anything more than that we simply refer to as a polynomial. Now, as I said in the last slide, a polynomial in standard form will have descending degrees of the terms. So we're going to start with the highest degree. Now, how we know which term has the highest degree comes from determining the degree of any monomial. And so what we're going to do is we're going to add the exponents of the variables of that monomial. So for instance, if I have the monomial 7x, there's an invisible 1 here. This is a degree 1. But if I have something like 4x squared y to the third, this is actually a degree 5 because 2 plus 3 is 5. And this is one term. So the degree of the polynomial will be determined by the degree of the first term when written in standard form. So again, we're going to start with our highest degree and work our way on down. Now we have names for different polynomials based upon what the degree is. If my degree is 0, meaning no variables are there, that is called a constant. If my degree is 1, that means that it is a linear polynomial. Those are things like y equals mx plus b. If I have degree 2, that is a quadratic, and we just spent the entire chapter 4 talking about quadratics. We have a name for degree 3, that's called cubic, degree 4 is called quartic, and degree 5 is called quintic. So we can classify every polynomial based upon how many terms it has and what the degree of that polynomial is. So let's look at our first example. Before I do anything, I have to put this in standard form. So I'm going to start with the term with the highest exponent, that's 5x to the fourth. And I'm going to then go with the term with the next highest exponent, that's 3x to the third. And because it's positive, I'm going to put plus and then minus x. So now I'm going to count. I have 3 terms. 3 terms is called a trinomial. Then I'm going to look to see what the degree of the first term is. So the degree of the first term is 4. Remember from the previous slide, 4 means it is called quartic, a quartic polynomial. So putting those two things together, what I have is a quartic trinomial. And so again, we have to put it in standard form before we can make a decision about how many terms it has, and what the degree of the polynomial is. So let's look at our second example. First, we're going to put it in standard form. So negative 4x to the fifth is what we're going to start with, followed by plus 2x squared. And then notice that 3 and 10 are like terms and can be put together. And so we now have negative 4x to the fifth plus 2x squared plus 13. There are 3 terms. This is called a trinomial. And the degree of my first term is 5. And so we have a name for 5 that is called quintic. And so what we have here altogether is a quintic trinomial. So I would suggest at this point that you pause the video for a moment and see if you can do this third example on your own. First, put it in standard form. Then look at how many terms there are altogether, and then look at the degree of the first term. And that will give us what type of polynomial it is. So is it a monomial, a binomial, a trinomial, or do we just call it polynomial? And based on the degree, is it a constant, a linear, a quadratic, a cubic, a quartic, or a quintic? We don't actually have any names for things higher than the 5. So hopefully you've paused the video before coming onto this, and so when I put this in standard form, I'm going to start with 4x to the third. The negative 3x and the 7x are like terms. They get combined into 4x, and then the minus 3. I have 3 terms. I have degree 3. That means that this is a cubic, because that's what degree 3 is, trinomial. All right, the last part of this first video is going to give us some information about the graph. So what we learn is that the degree of the polynomial will tell us the maximum time that a graph turns direction. So by turning direction, if we look at a parabola, it's going down and then it's going up. That's one turn. And so here's what we have to be able to look at is with any degree, how many turns will we get? So here's what we want to do. A degree 1, that's a line. So degree 1 is a line. So I'm going to put over here in parentheses that that's a degree 1. We know from chapter 4, again, that if it's a degree 2, that is a parabola. And so it turns once. So degree 1 has no turns. Degree 2 has 1 turn. Now, if we could type into our calculator a degree 3, we would end up with something that looks kind of like this. So this is degree 3. And notice that it changes direction twice, or it has 2 turns. A degree 4 is going to look something like this. And so notice that with a degree 4, it has 3 turns. So hopefully by now you are beginning to get the pattern. We have 1 less turn than the degree. So if I have a polynomial function of degree 9, it would mean that it could have up to 8 turns. So when we get to the second video that we have, we're going to spend a little bit of time talking about how all of this works with the graphs of our functions.